Hello and welcome. This is the fourth video of the series for CSIR UGC Physical Science June 2019 solutions. And we have the question which is something like this. An object is dropped on a cushion from a height of 10 meter above it. On being hit, the cushion is depressed by 0.1 meter. Assuming that the cushion provides a constant resistive force, the deceleration of the object after hitting the cushion in terms of acceleration due to gravity g is. Now, let me explain what is happening here. So let's say we have a cushion and an object is falling under gravity, and this height is 10 meter. And the second scenario is after impact the ball is 0.1 meter, so this is 0.1 meter inside the cushion. So basically it is depressed by 0.1 meter. Okay, so there are multiple ways you can do that. You can use the differential equation and then integrate it from height 10 meter to 0 meter and then use conservation of energy. But one of the easiest way to solve this is just use the potential energy conservation formula. So at maximum height you know the potential energy, and at the minimum height you know the potential energy, and both is conserved. So initially you have mgh where h is 10 meter, and in the second part you have mg prime h prime where g prime is the deacceleration, right? Because due to acceleration the ball is falling down, and due to deacceleration there is a depression and the ball stops after 0.1 meter. Okay, so what you can do is to find the deacceleration, just equate the two equation. So now what we have is since mass are same, so we can cancel out the m. What remains is gh equal to g prime of h prime, and here h is 10 meter and h prime is 0.1 meter. Then we have 10g is equal to g prime times 0.1, then g prime is equal to 100g. Okay, so this is the correct answer. So this is quite an easy and simple way to solve this kind of problem. Hope you liked it, and if you like our video, do give a like, comment, and also subscribe to our channel. Turn on the notification so that you don't miss another upload. And I thank you all for watching.